start. So it's all the factors of the last number divided by all the factors of the first number. So let's make some room here. Okay, so that means I'm going to take my 1, right, and divide it. I'm going to divide my red 1 by this 1 and by the 2, right? So 1 over 1, 1 over 2. And then I have to take my 5 and divide it by the 1 and the 2. Right, so those are my 4 possible answers for this equation. So this one's nice and short, but some of these numbers are going to have a lot of factors. Okay, yeah, you're good. Huh? It's a 1 and a comma. It's just a very straight comma. Okay, so are you good with how I got factors here?
Yeah.
Okay, so then I'm taking this 1 and dividing it by the blue 1 in here. Let me make them blue. That might be easier. So I divided it by the blue 1 and the blue 2.
So those are the answers?
Yes. Right, so I took 1 divided by 1, 1 divided by 2. And then I'm taking 5 divided by 1 and 5 divided by 2 to get the next ones.
So is it just like there's only a 2 that's right or something?
Yeah.
Okay.
Yeah, and then later we'll learn how to figure out what to narrow it down, right? But we need a starting point.
Yeah, my bad.
So, no, you're good. No, you're just thinking ahead, which is good. Yeah. So only some of these, but these are all the possibilities. Like, we can't have anything else. Like, it's not going to make sense if we've got, like, a 17 in there, right? So it's narrowing down our list from infinity to 8, technically, because you got positive and negative. Yeah. Yeah, we'll do another example here in just a second.
So you just leave that non-aligned?
Yeah, I mean, if you want to, you can simplify it. So technically, you should have plus or minus in front of each one. That gets really tedious. I'm okay if you just put like a plus or minus in front. So your options are, so 1 over 1 is 1, 1 over 2 is a half, 5, and 5 over 2. All right, so simplify them because sometimes they'll double up as you go to simplify. So you can just shrink your list down. In this case, they didn't, but in some of the other ones, they will. All right, let's look at a good one here. Okay, everybody good with this slide? Yes? Okay. So let's do an example. Let's say we have right, so even when we've got something really long like that, right, you are still only looking at the first number and the last number. I think I highlighted those backwards from last time to be consistent. Okay, so let's think about all of our factors of 18. We have what? 1 and 18.
2 and 9.
3 and 6. Yeah, I'm just making them a list just because it's a little easier with this. Yeah, so that's all our factors of 18, right? So everything that multiplies together to give us 18. What about our factors of 7?
1 and 7. 7.
Yep. Okay, so now we have to take all of these red ones and divide them by the blue ones, right? So, like, we're going to take this whole list and divide it by 1, right? Which just means, and then the whole list divided by 7. Right, so when it's divided by 1, that's fairly straightforward, right? We get 1, 18, 2, 9, 3, 6. Then we're dividing by 7, right? I'm putting my plus. So then 1/7, 18 over 7, 2 over 7. Okay. No, you can't reduce any of those either, which is fine, but there's your answer. Does that make sense?
Yeah.
So again, we're looking, you take all the factors of the last number divided by all the factors of the first number. So again, it can get a little tedious, but that's just kind of the theme of this section, is that it's all tedious work that takes forever. Questions on the rational zero theorem? Okay. Easy enough. Okay, so then now we're looking on page 120 with what is called the factor theorem. So again, the list we had was all the possible solutions, but this kind of helps us figure out whether it is a solution. And not really the easiest. An easy way to do that is to just plug them in, right? So if you look at the example on the bottom of 120, it says determine whether x plus 2 is a valid factor of the polynomial. So I'll write that up here. Right, this is just the example in your book. I'm just kind of copying it on the screen. So it's asking if x plus 2 is a factor, right? So remember when we factored, what did we do to the factors? How did we get an answer from that?
Multiply the first one and the second.
Well, no. When we're factoring a quadratic equation to solve it, what's the last step? We take the factors and set them equal to 0, right? So kind of the same thing here. So if that's a factor, we need to figure out if... So then solve that. So we're trying to figure out if x equals negative 2 is a solution to that. So that means we're going to plug negative 2 in for x and solve it.
Okay.
And see if it equals 0, right? We want this to equal 0. Okay, so we have negative 2 to the 4th minus negative 2 cubed minus 7 times negative 2 cubed squared. That should be squared. I copied it wrong. Sorry. I was like, cubed twice doesn't make sense. Squared. Minus 2 plus 6. So negative 2 to the 4th is what?
8.
No,
Oh, wait.
16.
Yeah.
So, and remember, if it's a negative number to an even power, it's going to be positive, right? And then negative 2 cubed would be negative 8, right? So we're subtracting negative 8. And then negative 2 squared is positive 4. Times 7 is a minus 28. Minus 2 plus 6. Okay, so let's see. So these two give us negative 30. I like to add all my positives and negatives together. So then 16 plus 6 gives us
30 overall.
22 plus 8 is 30. So we get 30 minus 30, which is 0. So if you get 0, yes, it's a valid factor. If it's not 0, no, it's not. That's not one of our answers. Okay? So basically, you take, if it's a plus 2, plug in a minus 2. If it was like x minus 4, plug in positive 4. Opposite sign of that, plug it in, see if it equals 0. Okay? So that's the extent of what we're doing today. All right? So let's do, and then we get to do my favorite part tomorrow, and I'm very excited. You guys will like it too, I promise. Synthetic division. It's fun. It is fun. Because it's very straightforward. You got, it's just a pattern you do over and over and over until you get to the end. It's easier than plugging stuff in. Yes. All right, on page 127. All right, so let's do 2 through 10 even, and then 11 through 22 all. Okay. So the 2 through 10 is the finding the factors, and then the 11 to 22 is plugging in the numbers. All right.